Hello everyone, in today's tutorial we'll be learning how to levitate a magnet. I've assembled all the items needed for this tutorial, so let's get started now. So this is an Arduino D board, a motor shield board, a UQ LEVILAB sensor mount circuit with Hall effect signal leads, a solenoid with drive leads, an electromagnetic plunger, a USB micro B cable to connect the PC to the Arduino, a banana plug power cable to connect the power supply to the motor shield, four washers and 4 bolts, a Hall effect sensor, Allegro A1302, a disc neodymium magnet, straight and cross slot screwdrivers, a UQ LEVILAB frame made of aluminum, and office tape. So first let's start off by preparing a plunger. Wrap one turn of tape around the plunger. The electromagnetic plunger requires wrapping of tape to stop it from slipping or falling from the electromagnet. Next we will insert the plunger. Take note of direction of insertion. The electromagnetic plunger should be inserted with the pointy head facing out. This is the wrong way of inserting the electromagnetic plunger. Then we will add office tape. Put a piece of tape on top of the electromagnet as shown. This is an important step for later because if the magnet accidentally collides with the sensor leads will press against the plunger, causing a short circuit. Now we'll add the Hall effect sensor. Take note of the sensor direction and pin connection. The right way of inserting the Hall effect sensor is with the sensor edge and logo facing upwards. This is the wrong way of inserting the Hall effect sensor with the sensor edge and logo facing downwards. Inserting the sensor incorrectly may damage it. Then we will mount the solenoid to the frame. Use the cross slot screwdrivers to screw 4 washers and 4 bolts to mount the solenoid to the frame. Now let's connect the solenoid actuator to the Arduino. Take note of how we connect the solenoid to the Arduino. The right way of connecting the solenoid actuator is to connect it to the motor shield motor terminal 2. This is the wrong way of connecting the solenoid actuator to the Arduino. If it is connected wrongly, it will require an update for the software in several places. Then we connect the external power supply to the board. Take note of the polarity. You have to connect the terminal without the black tag to the positive port and the terminal with the black tag to the power negative port. This is the wrong way of inserting the banana plug power cable. The terminal with black tag indicates ground and is to be connected to the power negative port. Next, let's connect the Hall effect sensor to the Arduino. Plug the 3 wires coming from the UQ LEVILAB sensor mount circuit to the Hall effect sensor into the Arduino motor shield. The white wire to the analog sensor output A0 pin, the black wire to the ground, and lastly the red wire to the 5-volt pin. Now we'll set the power supply to 12 volts first and turn it off. Connect the banana plug power cable to the power supply. Then connect the US micro B cable from the Arduino board to the PC. Now we'll turn on the power supply after the USB micro cable is connected to the PC. Next, we will compile the Arduino code. So the magnet is able to levitate now, and we have come to the end of this tutorial. If you have any questions at all, feel free to submit them in the form below.